Everyone, welcome to my YouTube channel. So here today we are going to be looking at Hess's Law. We are going to be solving all these problems which will equip you for an exam. So now let's define what Hess's Law states. So Hess's Law just simply states that the total enthalpy change for a chemical reaction is the same regardless of the routes taken, provided that the initial and the final conditions are the same. So let me explain the definition first. So let me just rephrase it. So we are saying that the total enthalpy change for a chemical reaction is the same regardless of the routes taken, provided that the initial and final conditions are the same. So what you can just think of it is something like this. So just think of Hess's Law as you are at point A, you want to go at point D. So if someone goes like that, they will reach D. It is the same way even if someone goes like this. We are just interested in the initial and the final position. So this as a result is what we call Hess's Law. So we are saying that the total enthalpy change for a chemical reaction is the same regardless of the routes taken, provided that the initial and the final conditions are the same. So you can just think of it like this. So if you're asked Hess's Law, you can just draw A and your B, then draw two paths like that, then come up with your definition using those two paths. So that is Hess's Law. So as long as you add them, regardless of how you add them, but if you reach the same conclusion, that simply means to say you are going to have the same enthalpy change. So how do we do some calculations under Hess's Law? Let's begin with the simplest one. So let's say we have our A plus our B plus our C is the change in enthalpy is equal to negative 50. We have our C plus D is equal to E. The change in enthalpy is equal to 30. So they can give you two equations and ask you calculate the enthalpy change for A plus B plus D. So how do you do this? So if C is here and C is here, that means to say you can be able to cancel your C like that. After you cancel your C, since they are on the opposite direction, then you add your A plus your B plus your D that is remaining, plus your D that is remaining should be able to give you your E like that. So the change in enthalpy, as long as you have done that, you are just going to add them. So it will be your negative 50 minus the 30. So you are just adding them normally. So you have added these two. So this plus this will give you negative 80. So this is Hess's Law. So kilojoules. So basically this is Hess's Law. So that is how we do that. So that means to say under Hess's Law, if you have, let's say, your A plus your B is equal to produce, let's say, C. If C is let's say negative 30 kilojoules, that means if you have to change, you are beginning now with your C to produce A plus your B. This negative changes to a positive 30 kilojoules like that. So this is how we do Hess's Law calculations. Let's now begin answering questions that are examinable. One thing that I also forgot to mention is if you have your A plus your B should be equal to C if you have a 50 like that kilojoules. If you multiply 2 to these letters where you have your 2A plus your 2B should be equal to 2C, even this one must be multiplied by 2, which will give you 100 kilojoules. Likewise, if you multiply by half, so that the equation becomes half of A plus the half of B should be able to produce half of C, then even this one, it will be half times 50 will give you a 25 kilojoules. So that is how we do with these calculations. So let's now answer this one. So the question says that use the reaction enthalpies to determine the enthalpy change for the following. So we have our P4, a gas, plus the 10Cl2, a gas also, to produce 4 moles of phosphorus pentachloride, So how do we answer this one? So this is what we want to arrive at. We want to arrive at this answer. So since this is what we want to arrive at, we are going to be making these two equations be similar to the answer we expect. So let's write these equations. So we have PCl5 to produce PCl3 plus Cl2. The change in enthalpy is equal to 157 kilojoules per mole. Then we also have the other equation is P4 plus 6Cl2 to produce 4 PCl3. The change in enthalpy is equal to negative 1207 kilojoules per mole, like that. So now we want these two equations to form this. So you look at your first one. So let's call this one as our equation 1, as our equation 2. So if you look, PCl5 is on this other side. That means to say you have to reflect the equation. So you are going to say flip equation 1. So you are flipping this equation 1. Look, is there any number on PCl5? There is 4. So, and you are going to say and multiply by 4. By 4. Or I can just say, to save time, multiply 4. So we are going to say this equation will be, so we are going to begin with this. So it will be PCl3 plus Cl2 to produce our PCl5, like that. Then this enthalpy is negative, is 157, so it will be a negative. The change in enthalpy, since you have reflected the equation, it will be negative 157, like that. So it will be 157 kilojoules, like that. Kilojoules per mole. So then we are going to get the other one, which is our, we are going to look at this. So we have P4, So that means if we have P4 and the required is just P4 without a number, that means we just add. So we are going to just get this equation, P4 plus, it is 6Cl2 to produce 4 PCl3, the change in enthalpy is equal to negative 1007 kilojoules per mole. So this gives us a value that will be equivalent to, so in this regard we are going to cancel whatever is common. So as you can see, so as we said, we have to multiply by 4 to this equation. So multiplying by 4, we are going to write this. Let me keep it. So multiplying by 4 means, let me cut it. So multiplying by 4, we are going to have 4 PCl3 plus we have our 4 Cl2 should be able to produce 4 PCl5. Then even the enthalpy change should be multiplied by 4. So as multiplying by 4 means we are going to have 157 times our 4, it's negative for that matter, so we are going to have negative 628 kilojoules per mole, like that. Then when we do this, what we are going to get is that we are going to get this second equation. Since this second equation has got P4, of which what they want is P4 there, then this side they have this, which is also found on the other side. So we are going to get that equation and put it like that. So when we do that, we are going to compare. If there is anything common on different sides, you cancel it if the coefficients are the same. So as we can see, this and these are the same and they have the same number, like that. So we are going to cancel them. So we are going to do this. When we cancel, we are remaining with our P4 plus 4 plus 6. They are on the same side, so it will be 10Cl2 should be able to produce our 4 PCl5. Then we have the change in enthalpy will be equal to, so the outcome will be equal to negative 1835 kilojoules as our answer, like that. So this is our answer for this problem. Let's move on to our next one. So looking at this other one, how do you go about this one? So here you need to be very careful. So you identify what do they want. They want NO and NO2 at the end, and this equation has that. But one thing is, it has got O3 and the first one has got O3. Now you know to say you cannot flip this equation because you want NO to be the first thing. So that means to say you have to flip the second equation. So you are going to say, oh, the first one. So this is the first one. So the first equation is, we have our 2O3 to produce our 3O2. Then we also have our O2 to produce our 2O, like that. Then the last one is saying that we have our NO plus our O3 to produce our NO2 plus our O2. So what we are going to do is, this is our equation 1, equation 2, equation 3, like that. So we are going to say that flip equation 1. So we are going to flip equation 1. So flipping the equation 1 means, so the change in enthalpy for this one is equal to, we have a negative 427. This one we have the change in enthalpy is equal to, we have 495, and the last one, the change in enthalpy is equivalent to, let's reduce this, the size. So the change in enthalpy for this one is equivalent to negative 199, if I'm not mistaken, negative 199 kilojoules. So what we are going to do is flip equation 1, so that we have our 3O2 will be able to become, we have our 2O3, like that, and this one will become positive. So the change in enthalpy for this is a positive 427. Instead of a negative, it will become positive 427 because we have flipped the equation. So this is what we have. Now you are going to now compare with what you really want. So as we can see here, this equation has got O3, but it doesn't have a 2. Now we can choose to multiply by half on both equations, but since 3, if we multiply by half, it will be 3 over 2. We are going to avoid doing that. So in any way that you do it, it's still okay as long as you arrive at the same answer. So what we are going to do is write the 3 equations now. We are going to have our O2. It's saying that O2 should be able to become 2O, like that. So the change in enthalpy for this one is equivalent to 495. Now look at the final answer. O must be this side. So we are going to say on top, we are going to flip this equation. So flip equation 2, so that we have our 2O should be able to become our O2. The change in enthalpy will now become negative since we have flipped the equation like that. Then what we are going to do next is the third equation. Third equation has got O3, and this one has O3 this side, but it has got a 2. So we are going to say multiply 2 to equation 3. So to equation 3. So the equation 3, which is our NO, let me just lift this equation. So this is the equation in which we are going to multiply the two. So multiplying the two, it will be equal to so we are going to multiply by a 2 like that. So this gives us 2NO plus 2O3 to produce 2NO2 plus 2O2. So this change in enthalpy will be equal to 2 times negative 199. This will be equal to, it's going to give us a value that will be equal to negative 398 kilojoules like that. So this is what we have. So after doing that, we can now add them. So don't worry about here looking at the coefficient, it's 1. You can always divide at the end. So now we have we are going to say adding the three equations. So adding the three equations, we are going to get all these three equations and add them. So the first equation that we flipped is this with its enthalpy change. So we are going to do this, put it there. So this is what you do. You also write the other equation, which is this one. So this is what we have. Then the last equation, which is this one, we are going to take this equation and put it there. So after we do this, we can now add them. So cancel whatever is common. So we have things that are common on different sides. We have this and this. So that thing needs to be cancelled. What else can be identified? We have, so as you can see, O2 plus 2O2 is 3O2, which is here. So you can say that this is common because O2 plus 2O2 is 3O2. So we are going to have those. Then just cancel. We have this. So 1 plus 2 is 3. That's why we cancel that. Then this and this. After doing that, just add them. So we are going to have, we are remaining with our 2O, but we can begin with this. So we have our 2NO plus our 2O like that. So this is going to give us, what we are remaining with is this side, it's just our 2NO2. Then the change in enthalpies, you just add them. So you are going to press your 427 minus your 495. Then you have minus your 398 like that. So this is going to give us the change in enthalpy will be equal to negative 466 kilojoules like that. Then remember, it is similar to what they want in the equation, but not quite. So we need just 1 to be on every coefficient. That means to say we multiply by half. So getting this equation and multiplying by half gives us a value. So we say multiply half. So we are going to have our half multiplies everything. Half by this will give you just NO. Half by this, it will give you O. Then half by this 2, it will give you NO2. The change in enthalpy will be equal to, even half by 466, it is going to give us a value of negative 233 kilojoules like that. So this is how we answer that problem. Let's move on to our next problem. Looking at this other one, we have used the reaction and the enthalpy changes to predict the standard enthalpy change for this one. So how do we do this? So we want to find this equation using this equation. So we are going to use this equation. So we have our half N2, a gas, plus our O2, a gas as well, to produce our NO2. Then the enthalpy change is equal to negative 33.2 kilojoules. So we have the kilojoules. Then this other one, we have our H2, a gas, plus half of O2 to produce H2O, which is the change in enthalpy is equal to negative 241.8 kilojoules. We have our N2, a gas, plus our 2H2 to produce N2H4. The change in enthalpy is equal to 47 kilojoules. So the equation where we want to get, let me copy it and put it here. So using these equations, we want to get to here. So identify the first equation. You have half N2. N2, NO2 is anything showing here. We have NO2 here and NO2 is this side. So what we are going to do is, let's call this one as our equation 1, this one as our equation 2, this one as our equation 3. So as you can see, this N doesn't have a 2 and here it has a 2. So and it is on the other side. So we are going to say flip equation 1 and multiply 2. So that means getting this equation, so I'll just be getting the equations to be faster. So getting this equation, we are going to say this equation by, we multiply our 2. So multiplying a 2, we have the 2 like that. So 2 by half is just so before that, let's flip this equation. So flipping this equation means it will be NO2 to produce half of H2 plus our O2. Then the change in enthalpy will be equal to negative 30. Instead of negative, it will be positive 33.2 kilojoules like that. So after doing that, we multiply by the 2. So multiplying by 2, it will be 2NO2. Should be able to produce 2 by half is just this and this will cancel, so it will be N2 plus our 2O2 like that. So the change in enthalpy will change to a value such as 66.4 kilojoules like that. So 66.4 kilojoules. So we have one equation that is similar to the answer that we expect. So with this equation, what are we going to do? We go to the next equation, which is this one. So this one has got water. Do we have water here? So yes, we have water. And water, according to this, it should have a 2 in front and it should be on the other side. As you can see, it has a 2 and on the other side. So we are going to say flip equation 2 and multiply by 2. So we are going to say flip equation 2 and multiply by 2. So this gives us, taking the second equation, we are going to have our value so this value will be equal to, we have this, so we have to flip it, so it will be our HO, our H2O should be able to become H2 plus half of O2. Then the change in enthalpy will now become positive 241.8 kilojoules. So we are now going to multiply by 2. So it will be 2H2O should be able to produce 2H2. Then we have plus half by 2 by half, it will just be O2. Then the change in enthalpy will be multiplied by 2. So this value, when we multiply it, will be, so our 241.8 times our 2 will be equal to 483.6 kilojoules. So 483, 0.6 kilojoules. Then after that, we look at our final equation. So this is the other equation. So now, after we do that, we look at our final equation, which is this one. So this equation, it has N2, H2. We don't have any of these, but we have this. So as you can see, it's on the same position as where it is in this other equation, and it has got the same number. So you just lift it. So lifting it means you're going to put it there. So it will just be the same equation maintained. Where is it? It's here. So this equation. So you can just add the comments to say maintaining equation 2. Or maintain equation 3. Maintain equation 3. We are going to have something like this. Then finally, add the 3 equations. Adding equations. So we are going to get all these equations, the 3 of them. We are going to have our value, which is going to be here, and the other equation, which will be here, and the final equation, which is this one. So with this done, we are going to say, let's cancel whatever is common. So what is common? So we have our, let me be using the same color for what is common. Let's use blue. Okay, so where do we have things that are common? Water, not common. We have hydrogen and hydrogen here. They are common. What else is common? So basically, that's all the things that are common. Okay, so looks like these are the only things that are common. I hope there's no mistake. So from that, let's just add now. Let's see what is the answer they expect. NH2. Okay, so adding now means this, we have our, even N2 is common. So we can now cancel them. So this and this goes. What else goes? This one, they are on the opposite side, so you can cancel them. So then we are just remaining with our 2 NO2 plus the water there on this side. Those are the only things remaining. Then on the other side, you have your 2 plus 1. So this is both oxygen. 2 plus 1 is 3. So we are going to say should produce 3O2 plus our H2 N2H4, like this. Then the change in enthalpy will be the addition, which will be equal to, so if we add this, we are getting a value that is equivalent to, this will give us a value that will be equivalent to 597. So the change in enthalpy should be equal to 597.6 kilojoules. So we have kilojoules. So that is our answer for that one. Let's look at our last 2 problems. So this one is one of the most challenging in this video. So we have the enthalpy change of the reaction at 27 degrees Celsius are these. Now from the above, calculate the heat change. They are not asking for the enthalpy change, heat change. But first let's calculate the enthalpy change, then use this formula. The change in enthalpy is equal to, we are going to have the change in the heat, which is U, the internal energy, plus minus, unless it's the other side, that's when you subtract. So minus that gas formula. So where R, you will have to use the 8.314. So first find the change in enthalpy, then make the change in heat to be the subject of the formula by making this cross the other side. But let's first find the change in enthalpy, which we are finding using the same usual means. So the change in enthalpy will be equal to, we have our Na plus our half Cl2 to be able to produce this. Then we have our change in enthalpy of formation is equal to, according to this, we have negative 411 kilojoules per mole. The next one, it is our hydrogen plus our sulfur plus our hydrogen plus sulfur plus 2O2, can make a mistake, 2O2, to be able to produce this. The enthalpy of formation is equal to negative 811 kilojoules per mole. Then the other equation, which is our equation 3, which is our C, so we have our 2Na plus our sulfur. I'm just copying, so let me just copy. So this is the required equation. So as we can see, the first thing is that identify. So this is your equation A, so this is your A, your B, it's just that space. So we have our A there, we have our A there, we have our B, then we have our C, then our D, like that. So they want this equation, so sodium should be this side. Look at your equation 1. So your equation 1, sodium is the other side, and it lacks a 2. So you're going to say flip A and multiply 2. So flip A and multiply 2. So you're going to get this equation, flip it, so it will be sodium chloride, like that, to become our sodium plus the half of chlorine, like that. Then multiply your 2. First let's write the change in enthalpy. So the change in enthalpy by flipping this equation means it will change from 411, was it negative or positive? It was negative. So from negative 411, it will be positive 411 kilojoules per mole, like that. So after we do that, the next thing that we are going to do is we multiply by 2. So as we have said, we are going to multiply by the 2, which will give us a value of 2 by sodium chloride. It will be 2 sodium chloride. To produce 2 by sodium, it will be this, plus 2 by half, it will be that. Then the change in enthalpy will be equal to, so if you multiply your 411 by 2, it will be 822 kilojoules per mole. Then the next one, it will be equal to So this is the equation that we are going to get for this problem. Then let's look at our B. Are we going to do anything with our B? So our B is the H2 plus S plus, then let's look at the sulfuric acid. Is it showing in the equation? So sulfuric acid is showing and it only has one. There's one sulfuric acid and here there's one. So the only thing we are going to do is we are going to flip the equation. So just flipping equation B, we are going to have without multiplying anything. So flip B. So flipping B means we are going to have, where's our B? This equation. So flipping it, it will be sulfuric acid to become hydrogen, sulfur and oxygen. So we have sulfuric acid, so that is us flipping that equation, should be able to become our hydrogen gas plus our sulfur plus our oxygen, which is our O2, like this. So now the equation is balanced just the way it was, like that. We have just flipped the equation. The change in enthalpy was negative 811, but it will now be positive 811. So we are going to say our positive, the change in enthalpy is equal to positive 811. So it will be 811 kilojoules per mole. So with this, we have now our C. So if we look at our C has got sodium sulfate. Do we have sodium sulfate in the equation? So we have sodium sulfate on this side, like that. So this equation, it means to say we are going to maintain our C because we already have the sodium sulfate this side where it's supposed to be. So we can say maintain C. So maintaining C is us just getting this equation and putting it where it should be. So this equation will be, we have this equation, maintaining it here. Finally, we have our D. So our D is equivalent to this. We have sodium chloride or hydrochloric acid. It is lacking a 2 this side, but it is on the other side. So we just maintain it but multiply by 2. So we are going to say multiply 2 to D. So multiplying 2 to D means getting the same equation, which is this one. Now just multiplying the 2. So it will be 2 by half. It will just be H2 plus Cl2 should be able to produce 2 HCl. Then we have the change in enthalpy should be equal to negative 92 times 2. So 92 times 2, it will be negative 184 kilojoules, like that. So after we do that, we are going to get our value, which will be equivalent to this. So these equations are now what we want. Then adding the 4 equations, that is what we are going to say, adding the 4 equations we are going to have. So what we are going to do is that we are going to cancel now whatever is common on different sides. So what do we have? So this is our sodium. So sodium has got the same number, so we cancel it. What else can we cancel? So looking at the sulfur is the same here. Even this one there was a 2 here, if you recall. 2. So we have 2O2. So we cancel. Then we also look at chlorine is common, we cancel. Hydrogen is common, we cancel. After cancelling everything that is common, we can now be able to add the two reactions. So we have 2 moles of sodium chloride plus the only remaining is our sulfuric acid. This will be able to become, the only remaining thing is our sodium sulfate plus our HCl, 2 moles of HCl for that matter. So we have our 2 moles of HCl. 2 moles of HCl. So then the change in enthalpy will be equal to, so remember we have everything, the same things. Now we just have to add our change in enthalpy. So this was there's supposed to be a 3 there. So we have adding, so we have our 822 plus 811 minus 1082. We have 251 minus our 184. So we have our 67. So it will be, the change in enthalpy will be equal to 67. But they want the change in heat. So remember what we said. So we have the change in heat. We are going to have the change in enthalpy should be equal to the change in the internal energy or heat, which plus the N, the number of moles, times the number of moles of a gas, the change in the number of moles of a gas times the R times the temperature at that period. So that means to say, if this goes the other side, it will be change in enthalpy minus the N, the change in the number of moles of the gas, times the R times our T. So the gases change from, so the change of the gas, the change in nRT will be equal to the change in the number of moles of the gas from the equation is such that if you look at this equation, the only gases that we have is we have 2 moles of this gas, but here we don't have any gas, so we have our 2 minus 0. So the change in number of moles of a gas is equal to 2 from the product, so we can say product minus the reactant, which will be 2 minus 0. So that's how come we have 2. Then our R for this type of a problem, you shall use the 8.314. Then the temperature, it should be in kelvins. So the temperature in kelvins should be equal to temperature in degrees Celsius plus 273. Just remember that K is higher in the alphabet, so you need to add. So we have the temperature in kelvins is equal to, we have the temperature that we are provided with from the question is 27 degrees Celsius. So we add our 27 degrees plus our 273. This gives us a value of 27 plus 273. This gives us a 300 joules or kelvins. So with that, we can now calculate our change in the number of moles of the gas, R times T, which will be equal to, we have the change in the number of moles is 2 times the R 8.314. Then we have times our value of 300 kelvins. This is going to give us 2 times our 8.314. Then we multiply this by our 300. This gives us a value of our 4988.4 joules. Now remember, for us to use, as you can see, this is kilojoules, so we need to convert this value into a kilojoules. So to convert this into kilojoules, kilo is 10 to the power 3, so you just move 3 steps backwards, 1 2 3. So the Ng times RT will be equal to 4.9, it will be 4.99 kilo. If you want, you can say times 10 to the power 3, but where 10 to the power 3 is, we are going to say kilojoules. So we have the kilojoules like that. Therefore, finally, the change in heat will be equal to the change in enthalpy minus the change in the number of moles of the gas times RT, which will be our 67 kilojoules minus our 4.99 kilojoules. This gives us our 67 minus 4.99. This gives us a value of 62.01 kilojoules. So that is the change in the heat according to the question that was required. If they ask for the change in enthalpy, we could have ended the change in enthalpy there, but we go further because of that. Let's look at our last problem, which is in form of a statement. So we have this one. So we are told the heat of combustion for benzene and acetylene are negative 3,900 and negative 642 joules respectively. Finds the heats of the reaction per mole for the reaction. So for this reaction, they want us to reach this reaction using the information they have given us. So we are just going to say benzene, respectively. So you should know benzene. Benzene is this one, C6H6. So we are going to say this reaction, so combustion meaning burnt in oxygen, so we are going to say C6H6. When it is burnt in oxygen, you are going to produce the two byproducts are carbon dioxide plus water only. So now this is the reaction that you are going to write. Then you are going to now balance the reaction. So looking at this, we have how many moles of we have 6 carbons, so we are going to put a 6 here. So make sure that you don't affect this one, don't affect the C6H6, just balance these other things. So we have our 6 there. Then which else can we balance? So we have hydrogens, we have 6 this side, so we should have a 3 here, so that 3 plus times 2 is 6. Oh yeah, 6, which is here. Then count the number of oxygens. Oxygen here is 6 times 2 is 12 plus 3, that's 15. So even here we need 15 oxygens, so we can put a 15, but 15 times 2 is 30. So you put 15 over 2, which is 7.5. 15 over 2 times 2 is this, and this cancels. We are going to remain with our 15 like that. So after doing that, now you can write your change in enthalpy according to the information you are given. The change in enthalpy for this reaction is equivalent to negative 3,900. So the change in enthalpy is found to be negative 3,900 like that. So if this is the case, remember it should be this other side. So we are going to flip. So let's call this one as our A. Flip A. So that we have our 6 CO2 plus our 3 H2O to produce our C6H6 plus our 15 over 2, our O2. Then we have our change in enthalpy will change to be positive like that. Then after we have done that, we are going now to deal with this one. So this one also, acetylene, which is our C2 H2 will burn in oxygen. So C2H2 will burn in oxygen to produce carbon dioxide plus water only. So what we have is this. Then let's balance. So we need 2 carbons, 2 hydrogens are already there, oxygens are already balanced. So we have 3 oxygens, we have 3 okay, we don't have 3 oxygens here. This side we have 2, this side we have 5. So 2 by 2 is 4 plus 1, that's 5. So we are going to put our 5 over 2, so that we have 5 over 2 times 2. This will cancel to leave a 5 there. So that is what we have. So the change in enthalpy, as long as you don't affect this, the one that is being combusted, will be the exact value they have given you, which is equal to, we have just a bit, just reducing this a bit. So the change in enthalpy for this one is equivalent to negative 642. So the change in enthalpy is equal to negative 642 kilojoules, like that. So it's joules, not kilojoules, but joules, not kilojoules. So we have the joules there, we have the joules here. What do they want? So calculate the heat reaction following this, the heat of reaction following this. So we are going to have these 2 equations. So adding the 2 equations, we are going to have, so this equation and this other equation. Now when we look at this equation, we need 2 of them according to what we have, or we need 3 of them according to what we have. We need 3 here. So we say multiplying by 3, this equation multiplying by 3, it will be equal to, we have something like this, multiply it by 3. So when we multiply by 3, it will be equal to 3C2H2 plus 3 by 5, it will be equal to 15 over 2 O2, which will be equal to 3 times 2 is 6 CO2 plus our 3 times H2O is 3 H2O. Then we have the change in enthalpy should be equal to, so multiplying here, it will give us a value that will be equivalent to, we have our 3 times our 642, negative for that matter, it is giving us a negative 1926. So this is what we are supposed to write here. So when we are adding these 2 equations, we have this equation so we have what is common here, we cancel. We have 6 carbon dioxide, so this and this cancels. What else is common? Oxygen, we have 15. We have 15 here. So those are the 2 things that are common. Even water is common. So we are just remaining with our 3C2H2, which should be equal to, we are going to have our C6H6. Then the change in enthalpy will be equal to, we have our 3,900 minus 1,926. This is going to give us 1,974 joules. So that is how we deal with such type of a problem. Thank you very much for watching. But also just a reminder, if the change in enthalpy gives you a positive value, 1000, let's say like this, then that means to say it is endothermic, because endothermic involves heat, or rather the change in enthalpy is positive. If it gives you negative 184 as your final answer, as the change in enthalpy, it means to say this is exothermic, because heat is being lost to the surrounding. So this is that for this video. See you in the next tutorial.